Good morning, everyone. Predictive analytics, big data, machine learning, deep learning, those are all terms that live somewhere between the realm of buzzwords and technical terms that we as data specialists have to use every day. But there is probably no word that gets more press these days than artificial intelligence in our business. So since I've been given this opportunity to do the first talk at this year's Big Data Expo, I thought I was going to tell a story. A story about how we humans use machines and computers to extract data, value from our data, and also try to answer questions. Can we really go away and get away without using human as part of, the process when we're creating artificial intelligence algorithms? So just a bit about me, right? This is a question I've been trying to answer for a while now. So after wandering from industry to industry, playing with data, and using my skill set pretty much everywhere that you could think you need to use data for, I landed a job at Walmart Labs, which is the online section of Walmart, the larger retailer on earth. And so I actually had a position called Head of Metrics and Measurements. So I was in charge of a group of engineers and data scientists who were essentially trying to make sure that all the other algorithms that we were using were performing as well as they should. And so, interestingly, I had a group, depending on my organization, that was called the Human Evaluation Team. And so this is kind of relevant to what I'm going to show you today. So what kinds of things did we try to measure, right? So it really went all the way from making sure an algorithm is performing as it should, measuring accuracy, and more business centric metrics as well. And so that function was actually pretty interesting. And so the reason why it was very interesting is that you really get the whole range of measurements that you can think of. And eventually we ended up having this very specific role within the organization where we became the auditing team that was trying to pretty much give a go or no go to any other algorithms that was being used by the team and Walmart e-commerce. And so if you think this is straightforward, think again, because it's actually very complicated. The main problem there is that whenever you're trying to assess the quality of another model, you pretty much have to build another model, and then you're creating an entire chicken and egg problem that is really hard to get away with. And so very shortly after I started this team, I actually realized how hard the task was going to be. And so one of the reasons, if for no other, is that if you're trying to measure something like customer satisfaction, this is really something that involves some kind of emotional response from a user. And so unfortunately, computers can only be used for proxies there. Okay, so finally, I'm just so this is not very important for now, just you may have realized I was talking in the past tense, so this is because I recently moved on to a new role at a company called Atlassian, which most people know as the company that makes Jira, Confluence, HipChat, and lots of other software that other companies use to make software. And interestingly, even though it's not the same kind of business, I have exactly the same problem as a head of data science and machine learning there. So let's go back to e-commerce and let me tell you the story of how the human still is a very important part of the loop in machine learning. So I'll structure my talk in 3 parts. So first, I'll discuss the roles of humans together with big data through the lens of tag data. Then I'll tell you about an entire business that was actually built around this idea of using humans to improve your data sets. And so this is something that most people don't know a lot about, so hopefully I can show you a little bit of what's being done. And then finally, I'll discuss something called the human-in-the-loop paradigm, which goes into a brand new area of machine learning called active learning that is actually pretty popular and widely used in the industry. So let's get started. I won't teach anybody anything by saying that we're in the days now where we have lots of data to play with, and so this is we all realize how challenging also and how complicated that may be. So just it doesn't matter how many times you can hear this. It's just worthwhile to me to really give a sense, because it's just simply mind-boggling the amount of data we have. And so just to give, if I had to give one number to characterize big data, I would say this, right? Every 18 months or so, we're essentially creating as much data as the rest of humankind before us. Just think about it, right? I mean, so it means that a year and a half from now, we're gonna have twice as much data to actually process and look at. So this is really a spectacular amount of data, and it also requires us to grow our technology stack at the same speed. Why do we generate such a large volume, right? I mean, so there are two reasons for it. It's not because we are more active as a species, it's just because we're more connected and we have technologies that allow us to actually record things as fast as we do that, right? The other reason is that we have more and more variety of data these days. If you think 10 years ago, most of the data was actually textual data. Now you have videos, photo, and this is probably going to become the mainstream type of data that we need to gather from now, obviously incurring a space cost in terms of storing all of this data. And naturally, all of this is really a joy for data scientists. Why are data scientists so excited about this, right? I mean, so it is because that allows them to do machine learning, right? I mean, so since we're talking about this, let's discuss briefly the types of machine learning algorithm you have, right? So you have one type that's called supervised machine learning, which is essentially regroups classification and regression problems. And so when you think about it, this is something where you're trying to use past data, historical data, where you have a notion of an output to try to teach a machine to reproduce the same kind of behavior in the future. So that means that you need tagged data, right? And then the second type is essentially unsupervised machine learning, which is interesting in the sense that you're essentially letting the machine decide how it should cluster and group the data. And so it's also interesting because you don't necessarily require tag data. At the same time, this is the type of algorithm that doesn't necessarily bring you the most value, right? And the ones that we don't necessarily handle the best. So I can hear half of the room ask, okay, where does deep learning fit in there, right? I mean, so I like to remind everybody that deep learning is actually more of an architecture than really an algorithm per se, right? I mean, so as an architecture you can use for machine learning, it can actually be used as both. It can be either used for supervised or unsupervised machine learning and algorithms. And if there is one thing we know about deep learning is that it requires a lot of data. It's an extremely greedy type of algorithm. So bottom line, if you want to use deep learning as a supervised machine learning algorithm, then you're going to have to tag a lot of data. Gathering data, tagging data can get actually pretty expensive, right? I mean, so imagine that you're trying to create an ImageNet data set that people want to use to actually build image recognition algorithms. It's going to require a lot of people checking what these images are. And obviously, it's also something that's pretty hard to scale, right? Which means that you often have to rely on sampling, which means that you don't necessarily have all the tools that you need and all the data that you need to actually do a good job at modeling. Now, not all things are so bad, right? I mean, so take the example of e-commerce. You can actually get tagged data in implicit ways, right? I mean, so for example, if somebody searches for a specific type of item, they are suggesting an object, an item for sale, and they're actually clicking on that item, they're actually buying it. So this is a way to actually get implicitly tagged data. So this is really good for us. There are also explicit tagging strategies that don't necessarily require voluntary action from the user, right? Think of social media likes, right? I mean, you're actually asking for input from the user, but they don't really realize that this is data you're going to use. They just feel like they're expressing an opinion there, right? But sometimes you don't. It's not that easy to actually embed the tagging process as part of the process in whatever industry you're functioning, right? So some companies have tried to come up with proxies. Like there are very I would say nice and cute examples of like companies trying to do that. I don't know if you ever heard about this, but like there's something called Google Quick Draw. It's actually like a mini Pictionary game or whatever. They essentially like give you, draw me a hammer. People draw a hammer, and they actually use the data to actually create a handwriting to icon algorithm. So they find ways around this, actually make it fun, and you don't even realize that you're providing them with data. There are other strategies. For example, like some games have tried things like, hey, you're playing your game on your phone, and then instead of showing you an ad, I'm going to ask you to tag a couple of pictures, and then I give you a couple more lives for your game for free. But let's go back to our problem, right? I mean, so what is it about humans that is so important that, it feels like we can't ask a computer to do the job for us for now, right? And so I'd like to use an example for this. Picture colorization, for example, right? I mean, here you have this sample of fruit there. And for a human, actually, coloring this is a very easy thing to do, right? I mean, this is actually what human kids do all the time for fun, right? And so it would be pretty straightforward for a human to do that because they have notion of context, right? Context. So then go back to what it would mean for a computer to do exactly the same thing, right? So take the same picture. You would actually need 3 processes there. You would need to have like an image recognition process that would actually basically distribute the different fruits and figure out like which part is the pineapple, which one is the banana. Then the next step would be to actually recognize what these items are, and then you would have to have a store somewhere that tells you like, hey, banana mostly are yellow, so I'm going to color that thing in yellow, right? I mean, so it's actually a lot more work, and this is for a pretty simple reason. It is because we humans have a lot of underlying uncoded knowledge that makes us pretty much like pre-trained algorithms. So I'm not saying that a computer couldn't do that, but it would take a long time and it would take a lot of data to actually train an algorithm to do that very same thing. So this is where you realize that you need human wisdom at scale, right? I mean, because you're going to have to have so much data that requires the input of a human that there is actually an entire industry that was built on top of that. So what is crowdsourcing, right? I mean, so it's essentially the process of getting labor or funding from a large group of people, from a crowd, right? So obviously it comes from the word crowd and the word outsourcing. And so the idea is instead of hiring a few people to do some work for you, you're going to ask a very large amount of people to do that. So some people might know, like a mechanical turf from Amazon. So this is exactly the type of thing that they do. The interesting thing to note here is that the word crowdsourcing was actually first penned in 2005, right? I mean, so if you think about artificial intelligence, then it's essentially following the same trends, right? So where you would think that artificial intelligence is taking over from crowdsourcing and human input, it's actually like 2 simultaneously developing trends. And so they've been growing parallelly the whole time. Crowdsourcing is really useful because it helps you with scale and it helps you with reach, right? I mean, think of the cases where you would have to tag images for cancer cell detection. You obviously need a doctor to be able to tag that for you. And so you're not going to hire doctors to do that just for you on purpose because that would cost you a lot of money. So you can get lots of things done with that. I've been mentioning tagging, but there are actually many other things you can do. You can even have crowds generate data for you. They can check the output of algorithms for you. They can do data curation for you as well. And they can even do everything I mentioned is like micro tasks, something that they can do really quickly, but you can also ask crowds to take on more large amounts of work. And obviously, you can ask crowds to like fund your project, and then give them some stake in your company, and then eventually start things from there. So if you're still not convinced that crowdsourcing is a real thing, there are actually many different applications that you may or may not know about, and sometimes people know about the application, they don't realize that this is generated by a human, about data that was human generated in the first place. Mapping, right? So I'm actually from Mountain View, California, headquarters of Google. So I see, the Google cars going by like really frequently. Truth is, most of the images you see on Google, like pictures of restaurants, are taken by people. And actually, you probably have seen that on your phone, like you're just being pinged and can you take a picture of where you are right now because we need more data. Traffic. So there is actually an app called Waze, which I don't know if it's very popular in Europe. It's actually something where if you're stuck in traffic, you're just going to post like, hey, I'm stuck in traffic over there, and then share that information with other people. It actually turns out that the accuracy of these models or this data is more accurate than what you would predict from a traditional approach. Translation, right? I mean, Google Translate is actually essentially based on people giving their input for translations. And then you have more exotic applications like epidemics. Like, for example, people would say, I live in this area, I'm sick, so you would just gather data of where is the flu growing right now. More than just application, there are actually entire companies that we sometimes don't even realize are based on the concept of crowdsourcing, right? I mean, so think of Flickr, think of Quora, for example, Waze, that I mentioned earlier, right? Even Stack Overflow, all the data you see in there is, absolutely not data that's generated by the company itself. Unfortunately, crowdsourcing comes with a lot of challenges as well, right? It would be too easy otherwise. First of all, reliability, right? I mean, so since we're talking about the case of retail here, for example, if I ask someone, do you think that this item is something that's relevant to a specific search query, they're still just judges. They're actually called judges. They don't actually have any financial stake. So if they tell you that this is awesome, they're still not emotionally involved in the process. You have more serious problem in other areas. So actually this app, Waze, had problems a few years ago because people were intentionally sending wrong information to avoid people from driving in front of their houses. So they would just report a fake traffic jam just across the street just to make sure that they were going to be able to sleep well. Then there is relevance of knowledge, right? I mean, so again, if I ask anyone in a crowd, give me some feedback on on specific item, baby food or dog food item, and they don't have a baby or they don't have a dog, that's information that I'm not interested in having. Subjectivity, right? I mean, so it's always it depends on what people think, right? I mean, you can say that this specific item is relevant to you, it might not be relevant to someone else. And then finally, speed and cost, right? I mean, so the problem when you're using such a large crowd of people, you can have problems related to the fact that I need people to do that now, not tomorrow, and it's pretty hard to actually source all of these things. So to try to resolve a little bit of all these problems, there were actually company created something called curated crowds. So curated crowds is actually people who are considered specialists in an area, e-commerce, for example, and all they do is tag data, validate algorithm, check relevance, and actually give their input on whatever algorithms you may have. And so it's supposed to be easier for you to manage because you don't have to look for these specific resources. It's also a little bit more expensive. So bottom line is there is an entire business for that. So in the context of e-commerce, this is the type of things they would do, right? I mean, they would do a catalog curation, just can you please tell me if the way that item has been classified, for example, makes sense? Can you check if the description matches the picture and this type of things? The other thing they do as well is search relevance. So you show them query terms and you show them what your algorithm would typically show for these results, and you would ask them do you think this is actually relevant? Then Then you have the whole concept of review moderation, right? I mean, so we may be pretty well versed in like sentiment analysis or whatever. It's still pretty hard to find the reviews that are the most offensive and be able to tag them. Then you have an entire business around mystery shopping, right? I mean, so basically, I will never get an algorithm, at least not in the near future, tell me that, hey, this new item is really cool, right? I mean, oh, this is something that is going to be popular in a few weeks, right? So let's go back to the example of search, right? I mean, so these are typically, I'm going to show you 2 examples of how we actually use it, right? I mean, so here you have comparison of 2 rankings. So the first line that you see is like ranking A, the other one is ranking B, just as you would for A/B testing, except you ask people to give you their preferences. Why is that better, or not necessarily better, but how is it different than A/B testing? One, you can ask them why they prefer one or the other. The other thing, you're not actually exposing the new algorithm to the users at this point. And so you keep some level of privacy if you're actually trying something really new. The other case is when you can use essentially like measure relevance differently. So that would be like validation of like a point-wise search algorithm essentially. So you show them the results you have, and then you ask them one by one, how relevant do you think that specific product is relevant to a specific search query? And so once you have this data, you can use this data to compute something called NDCG, normalized discounted cumulative gain, which is essentially like one of the best ways to measure relevance these days. And unfortunately, it's still not working as well as it should, but it gets pretty close to what the best we can do right now. So let's go back to machine learning again, right? I mean, so I mentioned human in the loop, right? I mean, so when do humans still outperform the machine, right? I mean, so I've given the example of like tag data, but like let's push that a little bit further. What is artificial intelligence about, right? I mean, so artificial intelligence is like the 4th industrial revolution, right? I mean, so the first revolution around like like steam power, the second one about like mass production, and then later on computers, and now we're on this brand new revolution, artificial intelligence. The common point is automation, and automation, the idea of automating things is not new. This is something we've been after for a long time. So, I mean, automation is, why is it so important for us, and why do we want to do automation? Because we want to take care of boring tasks, because we want to scale up, because we want to increase precision, and there are many other reasons why you would like to do that. So the thing is, most times automation is not that easy to achieve, right? I mean, you like even in like the most like advanced factories or whatever, you're still gonna have a human like cross-check the processes and everything, right? I mean, so this entire concept of like a model or a system that still requires some level of human interaction is called human in the loop. And again, it's not a new idea, right? Think of flying a plane, right? Most of the flight is handled by a computer, right? I mean, the pilot is not doing anything. They're just sitting there in case, right? And just taking care of like the delicate parts. So this is pretty much what we're trying to achieve with machine learning as well. And why do we want to do that? Because again, it allows us to keep an eye on the corner cases, and it allows us to actually override the decision of a computer when the decision of a computer is not good enough, or we don't trust it, or for any reason it's not where it should be. And this is all based on a principle called the Pareto Principle. So it's essentially what most people probably know as the 80-20 rule. So it's essentially that, going back to the fact that 80% of like happenings or the data can be predicted like pretty easily, right? I mean, and so essentially like 80% of the effect comes from 20% of the causes, which means reaching 80% accuracy is pretty easy, and then it becomes really hard. So the machine learning version of this essentially tells you that the best algorithms typically have 80% computer interaction, 90% human input, and 1% uncertainty or randomness that you're gonna use to balance everything. And actually, it turns out that this works pretty nicely. So go back to something we all know, right? I mean, so something that works really well in artificial intelligence or like deep learning these days is like face recognition, right? I mean, so if you go to Facebook, if you use Facebook at all, you know that you're gonna have a very nice tagging that says like this is such and such person, and the accuracy of this type of algorithm is actually really good. But the problem is always you're gonna get something like this, but how do you improve the 2 or 3% that remain, right? And this becomes really hard. So typically what you would see for Facebook is that they will ask you sometime, right? I think that this is such and such person. Can you please confirm? And so this is the way you would use human input, even in the most advanced kind of algorithms. Another example that everybody knows about is self-driving cars, right? I mean, so again, in Silicon Valley, you see these little cars everywhere. It's a little bit freaky at first because you're first time you see like a car drive without anyone in there. It's can be a little scary, but that's what it is, right? And so for a very long while, there was actually there were people in the cars to override the computer. So the car was driving on its own, but you had people just being there in case, record data, override the decision if needed. And so, again, they were using human-in-the-loop processes to be able to train an entirely new algorithm and build data, right? Think about driving, self-driving cars also have an amazingly high accuracy. Like, you can really trust them 99% of the time, easy, right? But 99% means that 1% of the time you're at risk, right? I mean, you're at risk of having an accident, even being killed. So this is something that cannot be accepted, right? I mean, so again, this is the type of situation where you cannot afford to actually trust the algorithm 100%. A fun fact that I like to share with people is actually I think Volvo actually had an algorithm that was supposed to detect large animals on the road. That was also based on image detection. Works really well. And then they started selling the car in Australia. And then actually the algorithm couldn't handle kangaroos because kangaroos don't move the same way than large animals in Europe or in the US. So this is the kind of thing where, you're a human, you just know that a kangaroo is just something you have to pay attention in the same manner than another animal, but the computer doesn't know because they don't have the context. So if you're still not convinced that, if you're the kind of person that thinks that, hey, it's just a matter of time before we get there, right? I mean, so you'll probably think of that example, right? I mean, so chess. In '97, right? I mean, Garry Kasparov was beat by an IBM supercomputer. End of the story. Human is beat, and what are you going to do about it, right? Truth is, after that happened, there were actually a spur of something called freestyle chess, and so it's a type of chess where essentially you can play with as many computers and as many people as you want. So it's really an hybrid set of teams. And so, interestingly, the best teams in the world right now, and actually I think the best team is a set of 2 people and 3 computers. So it's just still something that the human is not winning, the computer is not winning, really a mix of both that's taking the lead. So why is that? It's because computers are really good at tactical situations. But humans are better at strategy, long-term strategy, right? And it's really a combination of both that help you, essentially win at chess, right? Computers typically would allow you to forget about, as a human, you're just I shouldn't have done that move for chess, right? And computers wouldn't do that type of blunder. So that's definitely something they can help with. But long-term strategy is typically something that the human handles better. So that leads me into the area of active learning, right? I mean, so I hope that by now, you understand where I'm coming from, that the human is still important to actually build powerful, great algorithms. So how can we merge these together and have the best of both worlds? So active learning is actually a special case of semi-supervised machine learning where you're going to query an oracle, who typically is a human being, to actually give you some certainty or some answers around some data points that you have doubts about. And so this is essentially the general strategy, right? I mean, so for some of the data points, you know the answer because you know your algorithm is good enough. Some others, you have absolutely no data. You don't know how well it's going to perform. And then you have a subset of this data that you are going to decide to use humans for to actually tag your data and improve your algorithm over time. What's the benefit of this, right? I mean, so remember about tagging data. Remember when I said it's extremely expensive, and if you want to have a large amount of data, it's something that you're not going to be able to achieve easily. So guess what? Instead of tagging data before, you can actually build an algorithm and have just query the data that you really need because you know that these are the points that you have absolutely no certainty on. So it's pretty cool because it relaxes the assumption that basically you can just ask for data when you have a lot of uncertainty on this, and you can even turn the entire problem in an optimization problem when you are under a budget constraint. What data points should I ask about that's going to bring the most value to my algorithm, right? Knowing that I'm not going to get all the data that I want. So how does it work, right? If you go back to machine learning actually has 4 pieces, right? I mean, there's logics, like the piece you would refer to as algorithmics, data, optimization, and then feedback, right? And this is really where the human is important. Because, again, right, go back to my original problem of measuring everything and making sure everything works as it should, right? I mean, if you ask a computer to do that, then you're not really checking anything because you're again, creating this chicken and egg kind of problem. So you're really using a machine learning algorithm that is relying on the ability of pinging an oracle to reduce the mistakes or the uncertainty on some data points. So you can query the labels when you're uncertain about some of the data points, when basically you feel like you would like to have confirmation for some specific things. You can query data just to places where your model has changed, when you have retrained the model and you want to make sure that there's nothing wrong there. You can also query points just to reduce the variance of your model. So how does it change from the actual human-in-the-loop process that I stated before, right? So human-in-the-loop, again, take the example of flying a plane, right? The computer is flying the plane, and you have a pilot essentially say, no, I don't think this is the right thing to do, and they take over, right? But you don't necessarily take the data, they just override the decision. Then, if you want to, basically you can actually benefit from that data and re-inject that data in the loop to actually make your algorithm better, which is exactly what active learning is about. And so by creating this human in the loop, you can just have a system that corrects itself when it's got something wrong, and you can easily improve the algorithm over several iterations. So I'll just give you a really really quick list of examples where active learning is being used at Walmart that we actually kickstart. First of all, right, so something I call machine learning lifecycle management. So the ability of automatically maintain the machine learning algorithms that are in place. So what we do is essentially that we follow, failures of the models, and then we gather data from experts and we actually re-inject that. And so over time, we're creating automatically a data set. Diagnosis of catalog issues, right? I mean, so sometimes you just have a best-selling item that actually drops in the list, and you want to see why this happens. And so this is really a reinforcement-based kind of situation where you're just trying to learn from your own mistakes over time. And then you have an all optimization system through a query tagging algorithm. So basically, query tagging is the process where you'll try to split a query into different terms, like red t-shirt size M is actually 3 tokens. And so instead of tagging, getting these different tags for every single query, you just tag them when you know that your algorithm is, like not performing well, or like for example, like for some specific brands, we used to have that problem, so we just query the oracle in that specific case. So conclusions, right? I mean, so why do human and machine complement each other so well? Because humans are memory constrained and computers are knowledge constrained. And so when you put all of them together, it actually does something that's pretty good and pretty promising. Data, I mean, we're all excited about big data. I am very excited about big data, but like remember that for supervised machine learning, we still need to tag a lot of data, and sometimes that requires a human interaction. Then we are pretty like we're looking forward to the area where like the human in the loop paradigm and like active learning is going to be used more, because like I really feel that we should go into augmented intelligence before we go into artificial intelligence, because I really think that where we do the best job of all for now. Thank you.
Jennifer, thank you very much. I think I have one question before we move over to the audience. Can you give one example that you used within Walmart or somewhere else that you said, well, that was really impressive, or that went really wrong?
All right, so I'll say both impressive or wrong was like this example of machine learning lifecycle management thing, right? Because my team, again, was in charge of handling all of the other algorithms, which is a daunting task because you've got lots of different sorts of models, and you cannot afford to retrain them like very frequently. Obviously, e-commerce is a place where you're gonna have a lot of like trends, temporary trends, etc. So you have to have a system that actually maintains on its own. And so to do that, you need to be able to have like a way that triggers, like given an expert, we know that this model is not performing well or it's about to fail before it fails, right? Because if you just retrain when it starts failing, then you're too late, you're losing millions of dollars, right? And so it went really wrong at first because nobody really knew how they actually were supposed to be queried. So we were asking engineers, like, whenever you actually have a diagnosis, you input that into the system. And so that was brand new for everybody. So they didn't really know why they were doing it, the level of information they were supposed to put in there. But then eventually, after a few months, we started doing that. And so it went into something that, I'm not going to say that it's essentially like taking care of all the models on its own, but it was handling large cases of problems. We had a major drop in the number of failures we had after that.
Okay, thank you. Is there one question from the audience?
One of the big problems of the applications of artificial intelligence in real life is how to tackle ethical issues. Why should the autonomous car avoid the kid and run over the old guy and
yep.
So do you think that this advanced learning or alternative learning or whatever can actually solve that problem? So we always put the human in the driving seat when making the final decision about ethics,
yeah.
surgery, autonomous cars, whatever.
Yeah.
And we avoid all kind of stupid issues. How should artificial intelligence deal with impossible situations?
So that's actually a very interesting area, right? I mean, ethics and in data, right? I mean, so my personal view on that is definitely that if you put the computer completely in charge at some point, then you're like, how are you going? You're like the thing that you cannot reproduce in the system is emotions, right? I mean, is that something right or wrong, right? So my opinion is that we have an entire area that we need to develop there, where there's going to be ethics and there are going to be, ways for us to teach the machine what is the right thing to do. But I agree with you for that. For now, I wouldn't rely on any. There's obviously areas to actually tag data, generative adversarial models that are pretty promising to actually figure out on its own that a kangaroo is a kangaroo and should be treated the same way than another animal. But then, once you go into a child, right? I mean, is a child really, from a behavioral standpoint to a computer, it might look as an animal when you don't want to have the same rules or laws around this, right? So, I mean, for me, this is definitely something that you need to keep the human in the loop forever. But